what's being generated over there in the acid can, oh my word, is aluminium chloride and water. We expected reaction with both, yeah, I hadn't anticipated to be quite so vigorous. I hadn't expected it to be quite so, wow, that is brilliant. So this is obviously a very vigorous, hot reaction. We've got a lot of fume speed given off, which is a good job why we did it in the fume cupboard. You can see all that smoke being drawn up into the extraction fan. I honestly thought the acid would have done more damage. Because when you think of acid, you always associate acid as being the evil guy of the chemical world. I think those Pepsi cans have gotten off very lightly. They may have had their tops cut off, but they're far better than the Coke cans. Good old Pepsi for making them steel. Neil, can you clean that up for us? All over my arm. I don't wanna know that, babe. What's left is just the plastic around the outside of the can. All the rest of it converts to sodium illuminate. And that one's still going.
Acids are found in everyday life, from your own body to the things that we ingest. Also, just looking around at the items in your own home, you can find things on all different levels of the pH scale. The pH scale is used to determine how acidic or alkaline a substance is. The pH scale ranges from about 0, which is very acidic and something like battery acid, to a pH level of 14, which would be something like drain cleaner. Items on the lower end of the pH scale would include something like orange juice at a pH of about 3, including soda also. Bananas come in at about 5, milk at about 6.5 to 6.8, and some things above the neutral level, such as seawater, coming in at about 8, and ammonia at about 11.
I'd like to talk about two poisons that we can't live without. Talking about sodium and chlorine. If you breathe just a little bit of chlorine gas, it would do you in. You'd be out of here. You'd be a flatliner, just like that. You know what I'm saying? And watch what happens when we put just a small piece of sodium in water. Water like you might have on the roof of your mouth. It is pretty cool. These two chemicals, when they're separate, are dangerous. But when they're chemically bonded together, the pull of their electrons is so strong that they form a whole new substance, a whole new chemical called sodium chloride. For sodium chloride? Salt. Salt. Salt! Now our blood is salt water, our tears and sweat are salty, and so are potato chips. Thanks for joining me on...
When thinking about how important pH is in different places, such as nature, the easiest thing to think about is a fish tank. When looking at different ends of the spectrum, either way can really damage the bodies of fish. In freshwater aquariums, fish can thrive in levels about 6.5 to 7.5. And even some fish can be pretty sensitive to the changes in the water, such as cichlids, who actually do better in a higher pH level. pH levels matter so much for fish because water too far on either end of the spectrum can put their bodies at risk for different things such as disease and stress, which causes things like ick, seen in this picture. Okay, so what exactly is an acid and what is a base? An acid is any substance that contains a hydrogen atom that dissolves in water to form a hydrogen ion. An example of an acid would be hydrochloric acid. The hydrogen in this bond is actually what makes it so corrosive. Bases contain hydroxide and dissolve in water to form a hydrogen ion. An example of this would actually be sodium hydroxide. Now let's take a look at the Bronsted-Lowry definition. An acid is seen as any substance that can donate a proton, and a base is any substance that can accept a proton. Some Bronsted-Lowry acids, for example, would be acetic acid found in vinegar, citric acid which is found in any of our citrus fruits, which gives them their distinct sour flavor, and carbonic acid, which is how we get our bubbles in our soda that many people drink today. So what characteristics would you think about when you're looking at acids? Well, the first one that comes to mind is a substance that causes a piercing pain in a wound that you're trying to clean out. Like when you're using something like hydrogen peroxide. The next thing that you might think of is a sour taste. Obviously, in this picture, the baby might have eaten something like a lemon. Acids also have a pH less than 7. That's one of the main things that you're going to have to think about when you're thinking about acids. They produce hydrogen gas when they are reacting with metals, and then they also produce carbon dioxide when they react with carbonates. Some even more common examples that you might think of are lemons, oranges, urine, and even sulfuric acid. So on the other end of the spectrum, when you're thinking about bases, some characteristics you might think of are a slippery feeling. They might taste a little bit bitter. And then they would also have a pH greater than 7, which is the exact opposite of the acids. Some common examples that you might think of when you're looking at these things is soap, which fits the characteristic that I first mentioned, which is slippery. Then there's toothpaste. And then, of course, bleach, which also, if you think about it, has a slippery feeling to it. And then also, lime water is part of this too. So when looking at all these things, they each have some type of characteristic that was mentioned in the first place when you think about what a base
because
actually
you know
is.
I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, base. Yeah, it's pretty clear, I ain't no science fool. So you got litmus, well I can turn it blue. Make it go boom boom all over the place. When all the H plus meet all the OHs. Pink phenolphthalein, I think that's straight dope. Mix in a lipid here and it'll make it soap. You want it neutral, pH is low. Better set up a titration with a strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. If an acid gets in them, we just have to neutralize. You know I love me, my stomach, and all the things it dissolves. But my bowel that keeps it from eating my intestine walls. Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Ha! I'm gonna do the math to figure out the ratios to react. Stoichiometry, yeah, that's where it's at. And it'll tell you to prepare at least 1 molar for your strong hydroxyl drop. Yeah, my lab tech, she told me don't worry about your eyes. Cause if acid gets in, we can fix it with alkali. You know I love me, my stomach, and all the things it dissolves. But my bowel that keeps it from eating my intestine walls. Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Because you know I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, no acid. I'm all about that base, Ha. Ooh, 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 ooh.